Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Rollbar is real-time error monitoring, alerting, and analytics that helps you resolve production errors in minutes. And I talked with Paul Bigger, the founder of Circle CI, a trusted customer of Rollbar, and Paul says they don't deploy a service without installing Rollbar first. It's that crucial to them.
We operate at serious scale, and literally the first thing we do when we create a new service is we install Rollbar in it. Like we need to have that visibility, and without that visibility, it would be impossible to run at the scale we do, and certainly with the number of people that we have. Like we're a relatively small team operating a major service, and without the visibility that Rollbar gives us into our exceptions, it just wouldn't be possible.
All right, if you want to follow in Paul's footsteps and start deploying with confidence today, head to rollbar.com/changelog. Once again, rollbar.com/changelog. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Thursdays at 1 p.m. Eastern, 10 a.m. Pacific at changelog.com/live. Join the community and Slack with us in real time during the show at changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
Hello, and welcome to another exciting JS Party. I'm your host today, Nick Nisi, and I'm joined today by K-Ball.
I'm going to play you. Ahoy, ahoy.
Excellent. And we have a very special guest today, and that is Matteo Collina. Matteo, say hello.
Hi everyone.
Welcome to the show. To tell a little bit about yourself, you are a technical director at NearForm, and you're also on the Node.js Technical Steering Committee, where you've worked on things such as Node.js streams. Is that right?
Yes, absolutely. I am one of the few people that maintains Node streams, or ended up maintaining Node streams essentially. But that's, we can have a little bit of history there in the future, during the party.
Absolutely.
I'm also part of the OpenJS Foundation Cross-Project Council, representing the Node.js project. So, there is the Node.js project joined the OpenJS Foundation last year. So essentially there is a new entity, whatever that means. I'm also speaking at Node Interactive in Montreal in some weeks.
Yeah. You're speaking on December 11th in Montreal at Node+JS Interactive.
Yay.
We will be there as well. So we're really excited to see you there in person and see some listeners out there as well.
Yes, Nick, you're going to be doing a ton of stuff out there, right? You're like on a couple panels and other stuff.
Yeah, panels, a live show over lunch on the second day. So that'll be really exciting. And then we'll also just be hanging around and chatting with people. So that'll be a lot of fun. Come say hi.
Fantastic. I will, absolutely.
Awesome. So tell us a little bit more about yourself. What got you into being on the Node TSC or getting into streams?
Okay, so, I got into streams because, they underpins most of the things Node.js, really. At the beginning, I got into Node by working on top of LevelDB, the Level Up community. This goes a long time ago. We're talking about 2013 type of things. And at that point in time, I was doing a lot of work on streams and, thinking about streaming APIs and so on and so forth. When the Node.js Foundation was born and there was more loose contribution rules on the project, I just started, chiming in on streams, and I started contributing back to Node.js, and I started, fixing some of the long-term bugs that we had in there. I would say that the Node streams are probably the most legacy piece of software in Node.js to some extent. So at that point in time, I, kept working on it. Essentially, I almost inherited that code base. And because of that, they invited me to join the Node.js Technical Steering Committee. I am also, as part of my work at the Node.js Steering Committee, I'm also part of the team that organizes the Collaborator Summit, which is up and right after Node+JS Interactive. So where all Node collaborators and all OpenJS Foundation collaborators can meet together and have some sessions and discussions and meet face to face, which is pretty great. And it's a very nice experience. So as part of my daily job, I'm managing teams of people of developers, designers, DevOps, building things with Node.js and other technologies. Also a lot of React and so on and so forth. So NearForm is we invested a lot on Node.js, and we have several people on the TSC as well. James Nell, for example, or Anna Ensingen. The open source philosophy and Node a key part of what we do and what we are.
Very cool.
I'm curious to dig in a little more on one of the things you highlighted there. So you said streams are one of the most legacy parts of Node.
Yeah.
What do you think has led to them sticking around so long?
Oh, Node exploding. It's Node became so big so fast, and we couldn't change them anymore. Like changing streams now will be meaning to basically every web application built with Express will need to be rewritten. Well, every web application will need to be rewritten, or will be a significant amount of fixes. And then every single application, and then everything that does some file manipulation will probably need to be rewritten. So summing all those things up, this means probably all use cases of Node. So we cannot really do a breaking change on streams, a big breaking change.
Wow.
And that's the problem. So if the question mark is, should we do a new version of Node that breaks Express? Yeah, probably not, right? Or breaks Webpack or Rollup or whatever. And, probably not, right? Would you?
Probably not, though we did have it's reminding me like, okay, we could break this because it'll break every use case. It reminds me of the argument we had last week about whether we should rebrand JavaScript, right? Like once it's wide enough distributed, you really can't fix your mistakes.
No, you can't. That's the problem. And that's the problem of, we are slowly fixing them in the sense that we are slowly fixing some of the bugs in streams, some of the most problematic piece to some extent, like doing some surgical changes and, remove some of the inconsistencies, some of the problems, and so on and so forth.
Yeah. If you could probably, if you can keep the API consistent, you can replace a heck of a lot of the internals.
Yeah, the problem is that, it's not really the API that is the problem. The key challenge there is the event flow and the signaling messaging between two streams. So, if the event ordering changes, you can break somebody that expects certain events to happen in a certain order.
Oh, interesting. So people are depending on implementation details rather than the API.
Essentially, yes. It's streams are a very leaky abstraction in Node.js. That's one of the key parts that I don't like, for example. They're not well encapsulated to some extent. They expose a hell of a lot of internal workings of them, which is one of the greatest things so that people can do whatever they want with them. And this is great. On the other side, it also means that a lot of people are relying on internal implementations, details that probably they shouldn't have.
Right. So let's step back actually and clarify in case, we've got a lot of different folks with different backgrounds in the audience. So maybe can we start by defining what streams are and how they work? Okay.
So streams are like an array, but in time. A key thing of streams is that instead of, loading up a big file in memory or a big array of data, you are, consuming them as this data is loaded or produced. So by processing it chunk by chunk or item by item, you can actually process a huge amount of data with constant memory, which is great, for example, to, ingest a gigabyte, a file that is the size of a gigabyte or 10 gigabyte or a terabyte even, whatever, because we can just process them chunk by chunk and not, allocating all this memory that we cannot fit on our current machine. So they're great. And there are a lot more nuanced details in how streams work and how Node streams work and how streams work in general. So do you want to go into those details right now or?
I'd love to, but you mentioned that it's a very legacy part of Node, and touching them or breaking them in any way would break a heck of a lot of code. So that means that they are used in quite a few different places. Could you give us some examples of where streams might be used where we may not actually realize we're using streams?
Okay. HTTP server is using streams. So your request and response object are two streams, which means then whenever you're using Express or whatever web framework you're talking through, you're using streams and to interact with your clients. They are being used in every single database connection driver that you can work with. because our connection, our TCP sockets, our TLS stack is all based on Node streams. Essentially, even if you don't realize that they underpins it all, even if you don't use them directly, because you might just say to your database driver, oh, please do me an SQL query, or you're using a high-level HTTP client and you just say fetch a URL, internally it's using a Node streams to do all the work. And you can combine them. For example, if you're doing an HTTP call, you can use these that will return, for example, a compressed format with broadly gzip or deflate or whatever you want. You can then internally, your high-level HTTP client will probably spin up a stream to decompress them. Those are still shipped within Node.js in the zlib library. So this means that you can decompress your file, and all of these will happen. You will still get a stream in the end, which then you can process the way you want.
So for the most part, would you say that a lot of the use cases end up, you mentioned it being kind of like an array over time. From an end user's perspective, would you typically be using that array at the end when it's complete? And the streams are just kind of happening transparently under the hood for you?
It depends, okay? Because you might want to still processing the data chunk by chunk. So for example, once upon a time, I wrote, if you need to do, for example, if you want to process a big file, for example, you can parse all the events that GitHub is producing hour by hour using the GitHub archive. This is a new line delimited JSON file. So each line is a JSON. And you can use a stream to process those big files that are currently between maybe 300 megs unzip, which is big files. And you can read them line by line. So you don't have to allocate 300 megabytes of RAM in your system, because this will probably make your node process to be very slow or crash if the file is too big.
Okay, so you can instead just be alerted when a new line comes in and deal with them one by one.
Essentially, yes, that's it. So basically, you tell the stream start, and then you can use a module like split2 that will actually load the file line by line. And you can pipe it to a stream. For example, to read the file, use fs.createReadStream, and then you pipe it to split2, which will split it to line by line. Mm-hmm. And then at the end of it, you will have a line. So you can then consume this line in any way you want. You can use some other stream to write it to another file, or you can process it like one-to-one to store it in a database or whatever. Does it make sense?
Yeah. So essentially what I'm hearing is pretty much anything that's going to be dealing with data is likely going to use a stream because it wants to allow for the fact that you might have a lot more data than you want to deal with in memory.
Essentially, yes. Also, for example, if you are building a web app and you are receiving a file from an end user using a multi-part request, so, a file upload. Mm-hmm. If you're doing that, then if you want to support that, then you are receiving a stream on the other side. Because a user can upload 10 megabytes of data or 100 megabytes of data, and you don't want your application to be stopped waiting for that data to receive all those data and to be in memory before starting to process them, because you might want to store it to disk immediately. Otherwise, you might end up filling up your memory and you now have a nice security vulnerability.
Yeah. So I'm curious to explore. So you said you got into Node because you were interested in streaming data. What were some of the prior art pieces that inspired Node streams? What was done before that then influenced how Node streams came to be?
I don't have that answer for you. I admit my ignorance here. I don't know.
Yeah, no worries.
So, the key prior art, I think, is Unix pipes. And a lot of what Node streams are how Unix pipes are designed at a very high level.
That's actually a really interesting metaphor. So if you're familiar with piping things around Unix and thinking about things in that way, translating to a stream architecture within Node should be relatively straightforward.
Yes, exactly.
So maybe now we can dive in a little bit, because I think you mentioned that some things are getting changed. And I know that there is recently a new standard, WHATWG put out a streams standard. I also remember hearing James Snell talk about doing some sort of lower level type streams implementation as a part of his work when he was working on HTTP2 in Node. So kind of what's going on in terms of evolving this concept and standard within Node?
So there are two things here. You talked a lot of different things. So the first one that you mentioned is the relationship between Node and Node streams and WHATWG streams. The result is that Node became big and the Node streams happen to exist before WHATWG streams. So Node streams are prior art of WHATWG streams. And WHATWG streams learn from a lot of our mistakes to some extent, which is a good thing.
Yeah.
But this also means that Node became very big and everybody started using those. And it means that we cannot change them. We cannot drop them. So you cannot say that people can use WHATWG streams, essentially, because that will not be possible. There will be a lot of work anyway, and building a completely different new set of APIs for all the things that I mentioned that are not currently part of the Node community. So it will be a gargantuan effort, and if somebody wants to be involved in helping out in delivering some form of WHATWG streams compatibility, I will be very happy to help them develop this for Node.js. But at this point in time, it's a little bit too much work for the community to take on.
Are WHATWG streams right now, they're as a spec or as a standard, are they actually implemented anywhere either within or outside of Node? Like, does somebody have a library for this, or are they implemented in browsers?
There is a library for it. They're implemented in browsers. There is a library for it to integrate it with Node.js, essentially. But, there is not much compatibility overall.
Is it true that the browser's fetch is based on WHATWG streams?
True. That's the main usage of WHATWG streams, yes.
Got it. So just to reiterate to make sure I understood. So WHATWG streams are a new standard that learned a lot from Node streams, fixed some of the mistakes, but are not API compatible. They are implemented in browsers. So we have essentially bifurcated how to deal with streams, because I don't think Node streams are implemented in browsers anywhere.
You can use them in browsers if you want to, but there is no HTTP API to call. For example, there's not an equivalent for fetch because that's native in the browser itself, right? In the environment that the browser gives you. Got it.
Do you see over time those reconverging in some way? Like,
it's impossible.
No? Okay. So what do we do here?
Oh, so what we can do, we can develop some sort of compatibility layers so that, if somebody wanted to write isomorphic code, could potentially convert one to the other. But my take is, in fact, that both streams API are extremely too complex for end users and developers in general. So essentially, it's an abstraction that is too complex. And application developers don't want to cater for most of those cases. And in fact, whenever they have the chance, they will make mistakes. And I've seen so many mistakes using streams because it's a very complex API. But I've also seen mistakes using WHATWG streams as well. So it's very complex. It's a very complex way of dealing with data.
Mm-hmm.
Truth is, my personal opinion is that we should, in fact, not aim to be compatible between each other, but directly, but instead use a common lingua franca, which would tend to be, in my opinion, async iterators. Async iterators are great, and Node Stream supports them, and there was some changes to WHATWG streams last year to have them as well in that spec. I don't know if that has shipped in the browser or not.
This maybe I'm just completely misremembering, but I vaguely recall watching a talk by James Snell about where he started talking about, oh yeah, we're doing another sort of lower level implementation as a part of doing HTTP2 that might then get moved into Node streams or something. Am I just imagining this, or do you know what I'm talking about, Matteo?
So yes, I know very well because I was involved in some of the designs of HTTP2. However, what James was talking about something that is one level down, our public API of streams. Essentially, one of the key challenge for Node streams is that abstraction. Some part of that abstraction is also implemented in C++ and C. And because of that, there is it's too complex and it does too much. And it's hard to work with and maintain. And on top of that, also performance is a problem. So James wanted to do something more lean that could actually flow data faster from C++ to JavaScript and vice versa.
This episode is brought to you by Linode, our cloud server of choice. It is so easy to get started with Linode. Servers start at just $5 a month. We host changelog on Linode cloud servers and we love it. We get great 24/7 support, Zeus-like powers with native SSDs, a super fast 40 gigabit per second network, and incredibly fast CPUs for processing. And we trust Linode because they keep it fast, they keep it simple. Check them out at linode.com/changelog.
So digging back in, you mentioned the word async before we move on to async generators and iterators, but you also mentioned that the fetch API is based on WHATWG streams. And so I'm curious if any is the relationship between streams and promises, and does it differ between WHATWG streams and Node streams?
Okay, this is a very interesting question, and I have a nice answer for you. So Node streams are based on event emitter. And WHATWG streams are based on promises. And mixing event emitter and promises, you make some very nice popcorn. Don't try it at home.
Interesting.
Essentially, that's the key part. Or at least, that's a little bit untrue. The answer was, before Node 10, if you tried it at home, you will have a very bad experience. Because in Node 10, we had the support for async iterators, then you might have a way better experience right now.
Okay.
Than before. So historically, if you search for an historical guide on Node streams that doesn't use the new stuff that we added in the last year and a half or something like that, it's you would have a very, very bad experience. And with resulting on memory leaks, with like going to the memory leak territory in a matter of minutes.
Interesting. So let me think through that because I'm trying to make sure I understand. So Node streams, you said, are based on event emitters.
Yep.
Then the way that's working is you're essentially, conceptually, you're registering a listener that gets called multiple times.
Yes.
And then WHATWG streams, which I have not looked into in great detail, you said are based on promises. How does that end up? Does that mean that you're doing .then on them in some way?
Yes, you're really .then. You're using a board controller to cancel it and control the stuff. And it has a very complex API, more or less, to deal with, processing chunks and so on and so forth. So the key problem between one and the other is how you structure your application. So with event emitter is the system that calls you, okay? Mm-hmm. When you need to use a promise, you call the promise to get a value, okay?
Oh, interesting. So do you have to keep recalling to get new promises then, because your promise is going to be resolved?
It's a little bit more complicated, but yes, essentially yes. So it's a very basic level of, on emits multiple events at the same time, but a promise only gets you one. And this is the core difference between promises and event emitter, okay? So essentially the fact that they're based on very different building blocks means, this percolates in a huge amount of fashion. So the protocol is very different. It's the same concept and the same logic most of the time. It's just very different.
Yeah.
Because one is based on event emitters. One is based on event emitters and the other one is built upon promises. So in one sense, we could emit an event to get some data processed, while on the other side, they will probably call a method that returns a promise. So the flow is completely different. So in one case, in order to get a function called, I register a function called. In the other side, the function I pass an object and that gets called. It's completely different. It's a different approach to the same topic. So it's essentially mixing the promises and event emitter. You end up with some really bad things in there.
Yeah. I'm trying to think about it. You would. So in the event emitter approach, like the system is handling what is essentially an event loop, right? It's calling over and over again. In the promises approach, if you have an event loop, it's in user space where you're coming back and you're calling that promise over and over again. Yeah. Huh. Interesting.
And also there is one more thing that in event emitter, when somebody emits an event, that event is emitted synchronously, while promises are always delayed with the microtask queue. So just confuse things a little bit more because we were not confused enough. And essentially trying to reconcile those two words and provide a better API, it's been a very tough challenge. And this is where, for me, asynchronous iterators come in and more or less solves most of the problems.
I guess digging into how async iterators helps to make working with event emitter-based streams easier, and kind of tying off of what Cable had said, is it with that, it's just a cleaner syntax, being able to like for await and run that loop still in user space? Is that what makes it easier? Or can you dig into how async iterators help to?
So async iterator is essentially a specification for an object.
Uh-huh.
So this object has some very key methods. One of these is next. And next return a promise that will return the next data that will be read by the stream. Now, there is a catch in here because it will also error. It needs to throw that promise needs to reject if the streams as an error on itself or something like that. Does it make sense?
I think so.
Okay. So at that point in time, how do we reconcile this? So typically people in Node.js can consume stream using the onData event or using the readable event. Are you familiar with the readable event?
Let's cover it just in case, because while we may be, not everybody listening will be.
Not everybody listening. Yeah, that's true. So onReadable, what onReadable does, the developer, there is some data available to be read. And then the developer needs to call .read to consume that data. Now, there is also the onError event where an error might pop up. And this is where the problem of mixing those between event emitter and promises bites back, because you have in event emitter, with the event emitter, you have the error and the data being moved on two different channels, while on promises, they come on the same promise.
Oh.
And this is why it makes popcorn.
Yeah.
Okay? And trying to reconcile this and making sure that it has enough that, providing a cohesive API is very hard. And if you look at our implementation, you will probably scream because it's really intense. Let me use a nice term. It's intense. And it's very hard to get right. And, we had some bugs and so on and so forth before, marking it stable and safe to use. So it was marked stable, I think, at the beginning of this year or something like that. So it's now stable on both Node 10 and Node 12 and Node 13, of course. So you can use that safely. And essentially what we do is we use the readable event. So the readable event comes up. It's a signal that there is some data available. And then we call the read method on Node streams to read all the values that are available and queue them up to be consumed by the next, when you call next. So essentially, it will consume all the data that comes from next, that you call in next, and that will be it. And it works. And you can now, instead of doing that, so instead of using complex onReadable or onData that's very hard and error prone in a promise-based word, what you can do, you can just do a for await loop, because with for await, the JavaScript syntax will automatically call next for us, so we don't have to call it manually. And it provides a nice syntax on top of this protocol. And you can then just iterate over your stream just using JavaScript syntax. So you don't have to think about, complex APIs and anything. You can just use JavaScript, which is fantastic.
How often do you think about internal tooling? I'm talking about the back office apps, the tool the customer service team uses to access your databases, the S3 uploader you built last year for the marketing team, that quick Firebase admin panel that lets you monitor key KPIs, and maybe even the tool that your data science team had together so they could provide custom ad spend insights. Literally every line of business relies upon internal tooling, but if I'm being honest, I don't know many engineers out there who enjoy building internal tools, let alone getting them excited about maintaining or even supporting them. And this is where Retool comes in. Companies like DoorDash, Brex, Plaid, and even Amazon, they use Retool to build internal tooling super fast. The idea is that almost all internal tools look the same. They're made of tables, drop-downs, buttons, text inputs, and Retool gives you a point, click, drag and drop interface that makes it super simple to build these types of interfaces in hours, not days. Retool connects to any database or API. For example, to pull data from Postgres, just write a SQL query and drag and drop a table onto the canvas. And if you want to search across those fields, add a search input bar and update your query, save it, share it. It's too easy. Retool is built by engineers, explicitly for engineers. And for those concerned about data security, Retool can even be set up on-premise in about 15 minutes using Docker, Kubernetes, or Heroku. Learn more and try it free at retool.com/changelog. Again, retool.com/changelog.
So this reminds me a little bit of a concept when we first started dealing a lot with promises and this concept of asynchronicity. One of the things that came up was you can wrap a synchronous API in a promise to create a consistent asynchronous API, right? The asynchronous consumer doesn't actually care if it's getting something that was really synchronous under the hood, whereas going the other way is really hard. So in some ways, this strikes me as you're doing kind of the same thing, but in this case for batched streamed data, right? You're wrapping this sort of batched synchronicity that you get from the Streams API into an asynchronous iterator.
Well, it's slightly different than this.
Okay.
So there is a stream is by nature it's asynchronous, and I'm just transforming this from being event based on one side to be promise based on the other. And in order to do this, we need to use the pool-based API, which is this readable event, to read the data from the stream. That's fantastic. But on the other side, we need also to batch those data that we read in promises. Because when we are doing a for-await loop, there are two basic situations that can happen. Either there is some data on the stream to be read, or there is not. And if there is, we can just return a promise that automatically resolves with that data. Or if there is not, we need to return a promise, and then when that data will become available, put into the promise and deliver it to the code. And essentially we pool data and we wrapped it in promises. Now there's the third case. Is that the third case is the stream has error, and error in streams happens. They are emitted immediately when they happen. While in this mode, we will need to wait until the next call, the next round of the loop, to forward that event to the user, which is a significant change in how the system, in the order of events and the flow and the developer API essentially.
I have a couple questions on that. Can a stream recover from an error? Like, can it issue an error and then have subsequent data, or no? Once there's an error, we're done.
Well, no, it's a little bit more complicated than that. So it's down to how the stream is implemented. So this is true for Node core streams, but it's not necessarily true for everything else.
Okay.
Because it's a leaky abstraction, you see. So, we are trying to fix those slowly, but it's taking a significant amount of time. So.
Okay. So while for Node core streams, an error means you're done, that is not necessarily true of all streams. And then is there an ordering difference? So imagine from a stream, I'm getting 5 promises. And in the streaming world, I would get those 5 data, and then there's an error. And I would process that in order. So I'd process the 5 pieces of data, and then I would process the error. Now, when we wrap this up as an async generator, we may not have consumed all that data. Do we still have the same order? Like if we have put those 5 pieces of data in, but we've only consumed 1, and now we get an error, is the next thing we consume going to be another piece of data, or is it going to be the error?
It's going to be the error.
Interesting. So we change the ordering.
A little bit. It changes the ordering a little bit, yes. Because at that point in time, the stream has been errored, and essentially, if you're not consumed the data, so the point is, the data is there, and if you're not consuming it, if the socket gets down, the error will be presented to you on the next read. In order to keep the memory the consumed memory in constant, essentially, and as little as possible. The async iterator is not pulling data from the streams for you and queuing it for you. It's essentially reading only as much data that you are asking to read. So essentially, there are situations where the amount of two different implementation will have different ordering.
Yeah.
But in other terms, it's just that with async iterator, the async iterator model fits, it's way more ergonomic. And from my point of view, if your application is relying on the fact that, you are relying on this, you're probably have some bugs in your code, essentially, in your error handling. Because if a socket errors, it shouldn't really matter, this type of things. So you shouldn't really want to process those data that is lingering. And because otherwise you will be, you probably might have serious problems anyway. If you're sending a file, that will be truncated. So what the heck you are doing? If you're sending some messages, you definitely have an error situation. It's not end, okay? It's not the stream has ended.
Right. Yeah, it's not the same as end. So yeah, that is interesting though, because it creates a leaky abstraction where if someone had been assuming that was ordered and said, okay, I'm going to pretend that certain types of errors are kind of just ways of communicating data along with an end, that suddenly breaks because that's not a valid assumption.
No, absolutely not. Essentially not. Errors in Node.js are really bad things. Node.js has this assumption, and you can see that in the old error back model, where errors are really, really important things. It's not, application is missing some data. An error is, this is big. A socket has been destroyed. There's, the other party destroyed the socket.
Right.
Or, there's no network card anymore. That burned. A file that was supposed to be there does not exist.
Yeah, it's an interesting example of that. I mean, that's something that is not essentially convention, right? How the conventions of the project carry through into what you can expect to remain consistent versus not.
Yes, essentially, yes. It's a fascinating word, isn't it?
Yeah, definitely. And it seems very useful, even in places I didn't realize I was using streams. It's really cool to see that. And it's cool to see how much care is put into not breaking that very dependent upon API.
Yeah, that's the problem, right? Not breaking it.
Where do you see it going in the future? Do you see, like, if there were to be new stream-based APIs generated, would they be based on the Node.js streams, or do you think, in Node specifically, do you think they'd be based on this API, or do you think that they would try and implement something else, like the WHATWG streams?
My overall take is doing a stream-based API is extremely hard and extremely very hard to use because, people of Fetch, very few people use streams in Fetch. Most people use Fetch with .json. Yeah. In fact, if you use Node Fetch, as everybody building isomorphic application is doing, it's not. Node Fetch doesn't use WHATWG streams, and very few people notice.
Yeah, so it's an interesting point of, most folks are not interacting down at the level of the Streams API. So for dealing with all these sort of existing situations where streams are deeply embedded, do you see folks building a kind of layer on top using async iterators?
We already have one.
Okay.
Which is, for me, is async iterators.
Yeah.
Essentially, it's a basic compatibility layer for that problem that is simple enough, essentially, to be implemented on both sides with the same semantic. In fact, when we were working on our implementation, we have been working with TC39 and folks at WHATWG to be sure that they had similar behaviors or similar-consistent behaviors between the two. So that if you have processing some code from fetch or from HTTP.get in Node, you might have similar code to handle the data or something like that.
Are there any pieces of functionality or capabilities that are not handled by that compatibility layer?
So yes, there are, and there are not. We are working on them. So essentially, the key challenge here is you might want use this type of things to move from one side to the other to some extent. So essentially, you might want to use async iterators and async generators to be able to build and be able to combine them with streams as much as you want. And right now we have implemented, that you can async iterate a stream on one side, but we cannot async iterate. Like we can async iterate a stream, but we don't have currently an automated model at least, to convert that into a duplex, for example. Okay, we have missing a little bit the duplex abstraction and so on and so forth. And we are currently working on some of those topics. For example, we have recently added readable.from, which is an API that, given an iterator or an async iterator, it will just use those API to write the data to convert those data and put those in a stream. So in a node stream, so that you can use pipe or the pipeline operator, which is the pipeline API, which is different. It's a higher level API compared to pipe, to combine those without having to do much work. Now, this is very powerful. We are missing some equivalent, for example, for transform. For the transform API, there is a PR open that needs to be refined a little bit and boxed off and finished.
Got it. So reading from streams right now is well supported, and what's still under development is essentially pushing things back from async generators into streams so that we can use piping and transferring and all the sort of utilities that have built up around that. Got it.
Yes, we are working on it right now. So if you're interested, I can put some PR links into somewhere.
I think those would be great to drop into the document so we can put them into our show notes.
Yes, I'll just find those for you.
Great. Nick, I think you put a question in here as well about observables.
Yeah. I'm curious, Matteo, if you know, or is there a relationship between the problems that streams try and solve and problems that observables try and solve, and are they related?
So, in fairness, observables are not really common in the Node world, or at least not in what I use. So they are related, but I'm not so familiar with them to be able to say, it's a very similar problem. Observables only cater with the readable side of things, to some extent to the data emitting, not also the writable side of things, which is important to some extent. So that will be my main difference, but it's a similar problem to some extent.
Gotcha. So it's more that with observables, you have to still ask for the values, whereas streams would be calling you back.
Essentially, yes.
Very cool. That was a fascinating deep dive into the Streams API, the differences between the browser implementation and the Node implementation, which has been around forever. Thank you for that. As I learned, I use it a lot without realizing it. And so that's really awesome. Matteo, is there anything else that you want to say about streams?
There is one thing, okay, and it is a recommendation to everybody, okay? One of the greatest mistakes when using streams with async await and asynchronous and promises is to pass async function into an event handler. Like, for example, on data, and then you do async function something in order to use await inside.
Mm-hmm.
Don't do that. Don't. At least right now. The key challenge there is that it's error handling. So the problem is that, in the node, in a stream world, in order to clean up that resource, you need to call destroy on the stream. And in an async function can throw, and the problem is will reject. But the problem is that nobody right now is catching that rejection for you or doing something with it. So essentially what we will end up with likely a memory leak without you thinking this is the most normal thing to do. I'm currently working on a PR that actually does this, that fixes this problem by automatically getting a catch handler for you on event emitter, which is pretty cool. And I would love to do that. And this is going to probably land in the next few weeks. But it will be, opt-in and experimental for the beginning.
Very cool. That is something that I wouldn't have thought about, is that error nothing would be handling it. So
essentially that will create a memory leak.
Yeah.
In just a matter of, in case of error, it's very common. if you're receiving a multi-part file on a HTTP API, but with multiple key values and so on and so forth, in one of those cases, it was using, there was some code that I found that had a memory leak because handling one of those keys had an await in it, and it was throwing and nobody was catching it. And then the data then was, the stream was not being progressed anymore. So the request was stuck there, and you were basically keeping an HTTP request without any response at all up until the timeout existed. And that was, exhausting the sockets in the server. And then nobody could access your website anymore.
Yeah, the important things to think about.
I don't know. Maybe it was really deep. Okay, so I typically do this with a lot of explanation, with a lot of code examples, because with code examples, it's very clear to understand what I'm talking about. Come to my talk. There will be a lot of examples in code.
Yeah, it is. I feel like error handling with asynchronous code is something like we've made asynchronous code feel so much easier now because we have all this sugar around it. And yet we're often not handling a lot of the additional, or like a lot of the things that you would traditionally have to worry about there.
Essentially, yes. And there is also the fact that there is also maybe a substantial difference between Node.js and the browser. The browser has one human in front, and the server has, hopefully many humans connected to it through a browser or through a mobile app or whatever form. And this changes things dramatically in how tight it needs to manage resources, because most of the web apps done leaks memory in one form or another, and it doesn't really matter because there is only one user using them, and will maybe just if the tab crashes, or they need to restart Chrome from time to time, is not such a big of a problem. And it's very few applications like Gmail that needs to run for days. And that's one case. And on Node.js instead, you are not. If you leak memory, you are in big trouble, because then it can affect other users as well. It's a big difference there in the way how tight the error handling needs to be in one case versus another. Yeah.
Well, and I think even in the browser world, it's become much more important because increasingly, back pre-single page app days, you throw everything away and restart every new page.
Yeah.
But now you have an application that does all that navigation in JavaScript, and you're keeping stuff around for much, much longer. So memory usage is one of the big areas of where I think we need to both increase awareness and also increase our sort of layers of tools to make it easier to do right.
Yes, absolutely. And the one of the problems in that I find conceptually that can be a problem is how promises are specified and how they work. Mm-hmm. The beauty of a promise, if you call it that, if you can see it that way, because it's also very fascinating, is like showing a cat, and you don't know if the cat is alive or dead until you open the box, and that's a promise, right?
Yeah, that's funny.
And the problem is the key thing is that given a promise, you don't know if it will ever resolve,
right?
Or if anybody will ever open that box, and that is a key challenge for me. Because if I don't know if that promise will ever open a box, then how can we handle error properly?
Mm-hmm. Yeah.
It assumes that the runtime will manage, errors for you in a way that doesn't leak memory. That it's true for a browser where the environment is very limited, but for Node, where you can essentially do anything that an application can do on your server, that's very complicated. So that is kind of the source of the problem, probably. And the fact that on the web it's very useful to do fire and forget promises, or a lot of developers do. So a lot of developers do call fetch without putting a try catch out of it or a catch handler out of it. And if it just errors, it just errors and it goes into the console. Right? Mm-hmm. Not big of a deal. And in Node.js, if you start doing this, nobody will get a response from your HTTP call from your server. So, you need to manage all those errors properly and make sure that the right thing is done and applied everywhere. And certain fire and forget behaviors are not really acceptable in Node while they are on the browser.
Makes sense.
Thank you. I don't know. It's a lot of very deep topics. So I hope my explanation shed some lights, at least on my thinking and on the status of things.
Very fascinating, especially to hear the history of it and just where it's used, how it's used, and how the newer pieces of the language like async iterators are working with this better. So really great to hear from you on that. And yeah, we really look forward to seeing you at Node.js Interactive next month and catching your talk. Your talk will be on this, right? I believe the name of it is Stream into the Future.
Yay, yes.
Yeah, definitely more of a talk format for that to get a better understanding. And yeah, definitely check that out when it comes out. Thank you so much for chatting with us today, Matteo.
Thank you for having me.
All right, thank you for tuning in to JS Party this week. Tune in live on Thursdays at 1 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. And do us a favor, share this show with a friend or just have a podcast. Go into Overcast and favorite it. And thank you to Fastly, our bandwidth partner. Head to fastly.com to learn more. And we move fast to fix things around here at Changelog because of Rollbar. Check them out at rollbar.com. We're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out and support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. Thanks for tuning in. We'll see you next week.